Hey there. So let's discuss a very important concept related to grade 12 physics, electrostatics. And here we are given three cubes of iron and we are only looking at one of the faces of the cube. And this cube, since it is a conductor, we do know that all the charges, they are located at the surface. There are no charges that reside inside the conductor. We do know that, guys, right? And that's why the electric field inside the conductor is always zero. So now this is the charge distribution. So let me call this as the cube A, this is cube B, and this is cube C. So our main purpose is to understand that why the electric field lines are always perpendicular to the surface of the conductor. Had it been a regular shape or an irregular shape, I'll explain you through the irregular shape as well. Now this A cube made up of iron has positive charge on the surface, B has negative charge. So all the electric field lines are perpendicular to the surface and going outwards like this. All electric field lines are perpendicular and going outwards like this. Whereas in case of the negative charge, all the arrows would be directed inwards, right? Now we will discuss why this is so. So what will happen if the electric field lines are not perpendicular to the surface, guys? Right? That's what we are supposed to discuss. Hopefully you have understood that all the electric field lines would be perpendicular to the surface. I'm not drawing the complete diagram now, correct? And see, I will explain you afterwards. So why it is like that? So let me show it to you through a different color. Now guys, suppose electric field line in diagram A, say it is not perpendicular, right? Suppose we consider electric field in this direction, correct? Let's deviate a bit from the fact and let us understand, let us assume that electric field is not perpendicular. In this case, the electric field will have two components. One electric field parallel to the surface and another electric field perpendicular to the surface. Now guys, we are studying electrostatics, which means the charges are at rest. Now under this situation, it will be a violation of the electrostatic assumption. Here this E perpendicular is not going to do anything, but E parallel will push the charges along x-axis and the charges will be set into motion. E perpendicular has no role, agreed, because it is perpendicular to the charges and charges would not move under the effect of that force. But E parallel will set the charges in motion along plus x direction, which is not true, right? So that's why it cannot be in any other direction, it has to be perpendicular. So if an electric field vector is perfectly perpendicular to the surface, it will have no parallel components, and parallel components are the only one responsible for the movement of the charges. Similarly over here also, guys, if I take an electric field like this, which is not perpendicular, it will have two components, parallel and perpendicular. Again, perpendicular component will not do anything, it cannot push the charges inside because charges would try to be at a maximum distance, but E parallel will again set the charges into motion, which we won't like. We would be violating the approximation which we have made for the electrostatics, correct? So I had made the third diagram in order to explain that only, guys, but since you have understood, there is no need of this third diagram. Yes, but if you are given any irregular body and if the charge distribution is say positive, you make sure that you are first drawing the tangent to the surface. Suppose if you ask me find the electric field over here, show me, then I would draw a tangent and I would draw a perpendicular line to the tangent. This would be my electric field vector pointing in the outward direction if it is positive, if the charges are positive, and if the charges are negative, then of course it would be directed inwards. So this is a very important assumption that we must all understand before studying electrostatics.